In this lesson, we continue our work with the law of sines to cover what's called the ambiguous case. Here's our first example. We want to solve triangle ABC if angle A is 30, side B is 40 feet, and side A is 10 feet. Okay, we're going to draw a little reference triangle that we can label A, B, and C. Okay, angle A is 30 degrees. Side A is 10. That's this right here. And then side B turns out to be 40 feet. Okay, so according to the law of sines then, the only thing that I can solve for first here would be angle B. And what I'll say is that the sine of B is to 40 as the sine of 30 is to 10. So let's do that next. So the sine of B, the sine of B is to 40 as the sine of 30 degrees is to 10. So this is the law of sines, just like I used in the previous section, except here I'm saying the sine of an angle is to the length of the side opposite as the sine of some other angle is to the length of the side opposite it. So it looks just like the same ratios that we used in the previous section, it's just that they're upside down in this case. Let's solve for sine B. I end up with sine B is equal to, I'll multiply both sides by 40, and so I'll have 40 sine 30, all divided by 10. So sine B comes out to be, let's see, sine 30 degrees is just 1/2 times 40 is 20, divided by 10 turns out to be 2. So I end up with sine B is equal to 2. Now if you put this into your calculator, press your inverse sine button, you're going to get an error because there is no angle whose sine is equal to 2. The sine of an angle is always between -1 and +1, so it's impossible that this can happen right here. So there's no angle that fits this description, which means that there's no triangle that fits this description. And here's what's wrong. This side B, this side A right here of 10 is so small compared to this angle and this side that no matter where I put it, like this, I can never reach this side right here. So no triangle fits this description. So this is one case of the ambiguous case in which the given information yields no triangle. Let's try another example. This time angle A is 120 degrees, side B is 20 centimeters, and side A is 30 centimeters. Let's see what happens on this triangle. Now here I have an obtuse angle right here, so I'm going to draw my triangle in a little bit more detail. Since I know that angle A is an obtuse angle of 120 degrees, I'll draw my triangle like this. So there's 120, here's angle B, here's angle C. Side A is 30, that's opposite angle A, so I'll make that 30. Side B is 20 centimeters, it's opposite angle B, so I'll make that 20. And I'll look here and see what can I solve for first. Again, the only possibility is with the law of sines is for solving for angle B. So I'm going to say the sine of B is to the length of the side opposite, which is 20, as the sine of angle A, sine of 120, is to the angle opposite, is to the side length of the side opposite, 30. So sine B is to 20 as sine A is to 30. That's my law of sines. I'll multiply both sides by 20, and I'll end up with sine B is equal to 20 sine 120, all divided by 30. Now I work this out on the calculator, and this comes out to be 0.5774. So I have sine B is equal to 0.5774. Use my inverse sine button on my calculator, and this tells me that angle B, and let's see, I'm going to round to the nearest degree right here, angle B is 35 degrees. Or I also have to include this possibility, B prime is 180 minus 35, which comes out to be 145 degrees. Now I have to include this possibility right here because sine B equal 0.5774 and angle B is an angle in a triangle, it has the possibility it could be an angle between 90 and 180 degrees. Both 145 degrees and 35 degrees have a sine of 0.5774. So when I'm solving in a triangle like this, I have to include these two possibilities right here. Now, in this case, B prime equal 145 degrees doesn't make any sense because I already have an angle of 120 degrees. Another angle of 145 degrees is impossible because their sum would be bigger than 180 degrees. I have to include the possibility myself to begin with, but then I look and see that it conflicts with what I already know about the triangle. So in this case, I have one triangle that fits this description, and in that triangle, angle B is 35 degrees. So let's look at one more example. In this triangle, angle A is 38 degrees, side A is 41 feet, and side B is 54 feet. Now, I've drawn the triangle over here for reference myself already to save a little bit of time. You can see that I have angle A, the side opposite angle A. I have side B, so I can solve for angle B to start with. So the sine of angle B is 254 as the sine of 38 degrees, is 241. Now, I'll multiply both sides by 54, and I'll end up with sine B is equal to 54 sine 38 degrees divided by 41. I've worked this out on my calculator, and sine B comes out to be 0.8109. From my calculator, then, I know that angle B could be, using the inverse sine button, 54 degrees. But I also know myself that angle B could have a second value, so I'll call that B prime, 180 degrees minus 54 degrees, which is 126 degrees. So, again, I have to include this possibility myself. Sine B comes out to be 0.8109. I know B is an angle in a triangle, so it has to be between 0 and 180 degrees. Well, my calculator gives me this value when I use the inverse sine button, 54 degrees. Then I have to include this value myself, the angle whose reference angle is 54 degrees. So 180 minus 54 degrees is 126. Now I'll just check and see if this is a possibility. 126 degrees and 38 degrees, that's less than 180 degrees, so I do have two triangles that fit this description. In one of the triangles, angle B is 54 degrees, and in the other triangle, B is 126 degrees, and that's what I get if I draw this side this way, where that angle is 126 degrees. So you can see, here is my two triangles. One, the blue one that I drew in originally, where angle B is 54 degrees, and then this other triangle over here where angle B prime is 126. Notice that the length of this line is still 41. This line and this line have the same length, so angle A is 38, side A is 41, side B is 54, and angle B is 126. All the given information stays just like it was. So with the ambiguous case, you have the possibility of no triangles, like we saw in example 1. One triangle fits the description, like we saw in example 2, or this case where two different triangles fit the given information that we started with. So that's called the ambiguous case, and you get 0, 1, or 2 triangles.